Hey guys, Mr. Catlin here. We're looking at our virtual lesson 4.11. This is Wednesday, and we're talking about percent error, our last percent topic. All right. So, last one that we're going to do for the year, and then we'll have our quiz at the end of the week, and you guys will have a break. It's going to be good stuff. So let's jump right in here. Percent error is something that we've already been looking at already based on our double number line. So I put an example on here of what percent error is. Okay. So on our double number line, 100% is going to represent an actual thing, like an actual measurement or an actual height or an actual weight or an actual distance, the real deal, how big something really is or turns out to be. All right. And then there's going to be people that are going to be over or underestimating that real deal thing. All right. And they're going to be off. They're going to be off a little bit. And that's what we're measuring. We're measuring the percent error that they have based on how wrong they were, percentage wise. Okay. So you can see here the distance between 100% and the estimate that they made is the percent error. As always, let's do this with an example. I think it'll make more sense. Okay, so let's do this with the example of Sarah here. It says that Sarah estimated. Okay, so that means that she guessed it would take her 3 hours to finish her schoolwork, but it actually took her for real 5 hours to complete all of her schoolwork. So, what was her percent error? What percentage was she off? We can clearly see that she was off 2 hours in value, but we want that in a percentage on the double number line. So let's plug this in. Actually is 5, so 5 would go here. 100% is 5. She underestimated, so she would be over here at 3, right, for her underestimation. And our job is to simply find out what percentage that 3 represents, and then the error will be the distance between that mystery number and 100. So how far did she drop below the 100? So we can make a table for this. All right. The percent versus the value. And we know that 100% was 5. And now we're trying to find out what 3 would be as a percentage. Well, just because of quick division, I know that 100 will be divided by 5 and it'll be 20. So this is really just 20 times bigger, right? So 3 times 20 gives me 60. So 5 is 100%. That means 3 would be 60%. This would be 60% here. And the difference between 100 and 60 is a 40% error. She had 40% error. Now, the thing about percent error is she could have had that same error in the other direction if she would have gone up 2. If she would have guessed 7, 7 would have turned out to be 7 times that is 140. And 140 is 40% more or 40% overestimating. So that would have been 40% error if she would have guessed 7 or 3. So percent error works on both sides of 100. All right, let's go and let's do an example with this. Okay, a watermelon actually weighs 8,475 grams. All right, so I'm going to put 8,700 or 475 as my 100. A scale, which scales are synonymous for making mistakes. They're not all perfect. It measures the weight with an error of 12% under the actual weight. So 12% under would be like going down 12%. So they were down 12%. That would land us at 88%. And the question is, what was the measured weight that the scale made? What is this mystery number here? Well, we could use a table to figure that out. We could do our percent versus our value. We know that 100% is 8,475. We also know that we want to find 88% because he was 12% off when they measured the watermelon, right? So if we find that value, we've got our answer. We could use our constant and do that. There's also a shortcut here. I'm going to use that one for this particular one because I'm getting to be a fan of the shortcut. I hope you are too. If I want to find out what 88% of this number is, I can just multiply 0.88 times 8,475. And that will give me the same answer that I would have gotten working this table out over here. Because I believe that your constant was multiplying by 84.75, which you can see that that's very similar to this math that's being done over here. Okay. Either way that you shake it down, whenever you multiply that out, you get 7,458. So 7,458. That was what the scale read, but the watermelon actually weighed this much. It was off by 12% of its actual weight. And that's the error. This distance right here is the error that we're looking for. How much space between 100 and the decimal that's there. Okay. One more problem, then we'll call this quits for today. Okay. So we have this farmer, and I'm going to quickly sketch a double number line for this. Okay, we've got this farmer, and he's estimating that this tank has 27 gallons of water remaining inside. Okay, so my percent is down here, my 100 is there, and his estimation. So 27 does not need to be the number that goes over 100. 27 turns out to be an underestimate. So I'm going to put 27 down here, 25% below, that would be at 75%, right? So 75% of the real deal is 27 gallons, right? Because the error was a 25% error, right? So there's my setup. My double number line shows that I'm trying to find the actual weight of, or the actual amount that's in the tank, right? I want to know how many gallons are really in this tank if he was 25% below what it really was, right? So our table can help us with that. You could set up a table and do your percent versus your value in gallons, not galleons. We're not in Harry Potter world. 75% below, or 25% below is 75. So that's what we know. So that's really our starting point. And then we're trying to find out, okay, um, oh, I wrote that down wrong. 75% was 27, sorry. And we're trying to find out what 100% is, right? So we could divide those and find a constant of proportionality, and let's do that. So let's do 75, or I'm sorry, 27 divided by 75, and that gives me 0.36. So my constant of proportionality is I could multiply 75 by 36 hundredths to get this. So I should be able to multiply it by 100, and 100 times that just moves the decimal over 2, and it would be 36. So there actually were 36 gallons in that tank to start with. All right. Use those double number lines. Draw those tables. Sketch it out on your paper, especially on these that work backwards. There's not a good decimal shortcut for this one. So the table is the best way. You can't multiply 27 times 75%. It wouldn't give you that. You could, however, take 27. There is a decimal shortcut. It's a little bit tougher. You got to do the opposite here and divide by 0.75. And if you do that, it'll actually take you back up to 36, what it was in the first place. He underestimated by 25%. You guys have a great day, and good luck on your quiz later this week.